Okay. A person is standing with his arm outstretched in a horizontal position. The weight of the arm is 30 newtons, and its center of gravity is at the elbow joint of 27.5 centimeters from the shoulder joint. The deltoid pulls on the upper arm at an angle of 15 degrees above the horizontal at a distance of 12 centimeters from the joint. What is the magnitude of the force exerted by the deltoid muscle? So I thought this question was really interesting just because it deals with muscles and it shows how you can tie in physics to the human anatomy, and it shows what type of force has to exert to help other muscles pull and stuff. So the first thing I did was I drew a picture which kind of describes what's going on in the question, and the arm is in equilibrium. So we can apply the conditions for the equilibrium, which was, I think, the equation, which is that the sum of the forces is equal to 0, and the sum of the torque is equal to 0. So I was calculating the torques. I chose the rotation axis at the shoulder joint, so that the unknown force F sub s, which acts at the arm at the joint, has a 0 and produces 0 torque. So with only one unknown in the torque equation, I was able to solve immediately for S sub m, for F sub m, and in doing so, my first step was that the gravitational force is perpendicular to the line between the point of application and the rotation axis. So gravity produces a clockwise torque with a magnitude of the torque is equal to F sub r, which F times r, which is equal to 30 newtons times 0.275, which is equal to 8.25 newtons per meter. And then for the torque due to the F sub m, I was able to find the perpendicular, which is its line perpendicular to its point of application in rotation axis. Since the line is horizontal, I need the vertical component of F sub m, which is F sub m sine of 15 degrees. And then the magnitude of the counterclockwise torque is due to F sub m, which is equal to my equation here, which is torque is equal to the F perpendicular times r, which is equal to F sub m sine 15 degrees times 0.12 meters. And the sum of these torques is going to be 0. So with the sign convention, I have my equation here, which is going to be F sub m, which is going to be equal to sine of 15 degrees, which is times 0.12 meters minus 8.25 newtons times meters is equal to 0. So now I was able to solve for F sub m here. So I put my values in: 8.25 newtons times meters divided by sine of 15 degrees times 0.12 meters, and I got my answer to be 270 newtons. So that's the force exerted by the deltoid muscle on the arm, and this was really cool, and it just showed you how the body works with physics.